To wrap up our unit on quadratic equations, we need to look at their graphs, okay? You're going to deal a lot with quadratic equations when you get into a pre-calculus class, so being comfortable with the equations and their graphs, super important, okay? So a few things about the graph. First of all, when we have the graph of a quadratic equation, and keep in mind a quadratic equation is just generically y equals ax squared plus bx plus c, and we know that we do have a condition, and the condition is that a cannot equal 0, okay? If a equals 0, this squared term becomes 0, and then it's no longer a quadratic, it's simply a linear equation. So when you have y equals ax squared plus bx plus c, we have a graph that is called a parabola. And a parabola looks like this. So you can have a parabola that looks like this, or a parabola that looks like this. Okay, and those are graphs of quadratic equations. Okay, now I don't want you to confuse this with what we've seen in previous sections when we were talking about solving quadratics. When we're solving a quadratic, we use the form ax squared plus bx plus c equals 0. This is called standard form, and this is designed so that we can solve the quadratic equation. And that's really important, and we're going to talk more about what we're really doing with that in just a bit. But for now, y equals ax squared plus bx plus c. Okay, now the vertex or turning point of the parabola is the highest, which we call the max, or lowest, which we call the min, point on the parabola. So if we were looking at these two graphs that I've drawn, this point right here would be the vertex of that graph, and it is the lowest point on that parabola. This would be called a minimum or a min. We'll call it a min for short, but it's a minimum. Okay? Now, this point right here on this parabola, kind of wacky looking. But that point right there on that parabola, that is the highest point of that graph. So we would call it a maximum, or for short, just a max. Okay? So the vertex is a really, really important point on the graph, and it's a point on the graph that you need in your graph. So when you go to graph the quadratic, there are certain points that you need to make sure are included. The vertex is one of those. Now, a few other things about the vertex. If the parabola opens up, you have a minimum value, and this occurs when a, the coefficient of the square term, is greater than 0. So we would say this one opens up. So I'm going to kind of split this in half so we can. So this particular parabola, the first one, it opens up, okay? And this occurs when a is positive. So when the coefficient of the square term is greater than 0, so positive, we have a parabola that opens up, and it has a minimum point. Now, on the flip side of that, if we have a parabola that opens down, you have a maximum point, and this occurs when a is negative. So this parabola over here opens down, and we would know this from the equation if a, the coefficient of the square term, was negative. So when the coefficient of the square term is positive, you have a parabola that opens up, which gives you a minimum point. If you have the coefficient of the square term is negative, you have a parabola that opens down, and it has a maximum point. Okay. We also need to know that parabolas are what we call symmetric. Okay. So, these are hand drawn, so you kind of have to pretend. Okay. But if this was a perfect parabola, we would have this vertical line that goes right down the center of the graph. And if you were to fold the parabola along that vertical line, you would have the two sides of the parabola meet up perfectly. So parabolas are symmetric. And then even more important, maybe not even more important, but equally important, my dog's going to start barking. Maybe not. Okay. Just as important, we have the invisible vertical line through the vertex. So it goes through the center of the parabola, right through the vertex. It's a vertical line. This is called the axis of symmetry. And it divides the parabola in half, basically. Okay, so there is a vertical line that goes right through your parabola. We call it the axis of symmetry, and it splits your parabola exactly in half. Okay, now for example 1, what we're going to do is we're going to graph the parabola with the means that we already know. We already know how to graph equations using the point plotting method. So that's what we're going to do here. We're going to get the graph, and then we're going to kind of talk about some of these key points that we've already discussed. And then in future videos, we'll talk about some really important aspects of the graph and how to do certain things by hand. Okay, so example 1 says graph using the point plotting method. Now, generally speaking, you have to come up with your very own x's and your very own y's. So you generally choose x values, plug those into your equation, and solve for y. Okay. Now, this table, I've left it completely blank, but for the sake of this particular video, we're going to use these points. So I have gone kind of into the future and I've looked at this graph and I've chosen these x values very specifically. Okay, so what we want to do is we want to take each of these x values, plug them into the equation, figure out what y is. That's going to give us 5 ordered pairs that we can then graph. And then we can plot those points and connect them with a parabola. So let's look at what happens when x is -2. So we get y equals -2 squared minus 4 times -2 minus 5. Well, that tells me that y is going to equal, well, -2 squared is 4. -4 times -2 is +8. And then we still have that minus 5. So let's see what that equals. 4 plus 8 is 12. 12 minus 5 is 7. So that tells me that when x is -2, y is 7. So I would go back 1, 2, and then up 1, 2, 3, 4, 5, 6, 7. So that's a point we know is on the graph. And then we're just going to repeat this whole process. So do this again, but this time we're going to let x equal -1. So we have y equals -1 squared minus 4 times -1 minus 5. Well, -1 squared is just 1. -4 times -1 is +4. Whoops, and then we need to subtract 5. So let's see, 1 plus 4 is 5. 5 minus 5 is 0. So if x is -1, y is 0. So that point is a point on the graph. Now next up, we want to figure out what y is when x is 0. So y equals 0 squared minus 4 times 0 minus 5. Well, 0 squared is 0. -4 times 0 is 0. And then drop down your minus 5. 0 minus 0 minus 5 is -5. So when x is 0, y is 1, 2, 3, 4, -5. So that's another point we know is on the graph. You can't really see it. Let me do them in red so you can see them a little easier here. So we have this point, and this point. Okay, now let's go back and repeat. We've got 2 more points to find. So when x is 2, we get 2 squared minus 4 times 2 minus 5. So let's see, 2 squared is 4, -4 times 2 is -8, minus 5. So let's see, that's 4 minus 8 is -4. -4 minus 5 is -9. And certainly you can use a calculator if you need to double check these points. So we have 2 -9s. So let me go to red. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that point is on the graph. And then finally, let's plot or figure out what y is when x is 5. So y equals 5 squared minus 4 times 5 minus 5. So 5 squared is 25. -4 times 5 is -20. So let's see, 25 minus 20 is 5. 5 minus 5 is 0. So let's go back to red, and we've got 1, 2, 3, 4, 5, 0. So we have these points on the graph, and I'm going to try my hardest to draw a pretty parabola, but it's by hand, so keep that in mind. So we're going to plot these points. Not the worst parabola I've ever drawn. But there you have it. There is the graph. Whoops. I have no idea what that is. I mean, I know what it is. It's a star, but I don't know how that came to be. All right, so there's the graph of our particular quadratic equation. And let's notice a few things. We have 2 x-intercepts. We have this point right here and this point right here. And if we go back to our talk about linear equations, we know x-intercepts occur when y is equal to 0. Well, notice here, y is equal to 0 here and here. So we calculated our 2 x-intercepts, and those are really, really important points. Those are where we cross the x-axis. We also have this really important point right here. Well, if you look here, this is the y-intercept, and y-intercepts occur when x is 0, okay? We have this point right here, Also important, it is the lowest point on our parabola. So this happens to be the vertex. So this is the minimum slash vertex. Okay, so we found four really, really important points on this graph, plus another one. We threw another one in there just for the sake of fun. But what we always want to do when we're graphing parabolas is we want to look for x-intercepts, y-intercepts, and a vertex. Those are the important points, okay? Another thing I want to point out here, if we look at this term right here, a is equal to 1. So that tells me a is greater than 0. And remember, up here, we found that when a is positive, the parabola opens up. Does our parabola open up? Indeed, it does. So this tells me that the parabola opens up. Also, we have, let me do green. If we look right here, we have this vertical line right through the center of this parabola. This vertical line is the axis of symmetry. So the axis of symmetry is the vertical line through the center of the graph. So vertical lines are always of the form x equals. So the axis of symmetry here is x equals 2. So we have a lot of information here. So when we graph parabolas, now I very specifically chose these 5x values so that we would get very specific points on the graph. But when you're graphing parabolas, you need your x-intercepts. There's generally 2 of those. You need your y-intercept. You need your vertex. It's helpful if you understand the axis of symmetry. And remember, a, the coefficient of the square term, always tells us if our parabola opens up or if it opens down.